The mystery of antimatter. Why does it barely exist? Antimatter is one of the most intriguing and elusive phenomena in modern physics. According to the laws of nature, for every particle of matter, there exists a corresponding antiparticle made of antimatter. These antimatter particles have the opposite charge and properties compared to their matter counterparts. For instance, the antimatter counterpart of an electron is a positron, which has a positive charge. However, despite the fundamental existence of antimatter, it is incredibly rare in our universe, leading to one of the greatest mysteries in physics. Why does antimatter barely exist? The birth of antimatter. The theory of antimatter began to take shape in the early 20th century with Paul Dirac's prediction in 1928. Dirac's equation, which describes the behavior of electrons, suggested the existence of particles with opposite properties, antiparticles. His prediction was confirmed in 1932 when Carl Anderson discovered the positron, the first antimatter particle, in cosmic rays. For a long time, it was thought that antimatter should have been produced in equal amounts as matter during the Big Bang. However, as we look around today, the observable universe seems to be dominated by matter, with very little antimatter detectable in nature. This imbalance, known as the baryon asymmetry problem, poses a critical question. Where did all the antimatter go? The mystery of the imbalance. In the earliest moments of the universe, the Big Bang should have created equal amounts of matter and antimatter. When matter and antimatter meet, they annihilate each other, releasing energy. So, if equal amounts of both were created, they would have annihilated each other completely, leaving behind only energy in the form of photons. However, something must have occurred after the Big Bang to create a small excess of matter over antimatter, allowing the universe to form as we know it. Various theories attempt to explain this imbalance. One possibility involves slight asymmetries in the laws of physics, particularly within the weak force, which governs the interactions of subatomic particles. These imbalances could have led to the excessive matter that survived after most of the antimatter was annihilated. Antimatter in the modern world. While antimatter is scarce in the universe, it is not entirely absent. High-energy cosmic events, such as supernovae and cosmic rays, produce small amounts of antimatter. On Earth, antimatter is generated in particle accelerators, like CERN's Large Hadron Collider, where high-energy collisions create antimatter particles, like positrons and antiprotons. These particles are short-lived, annihilating quickly upon contact with matter, but they offer a glimpse into the world of antimatter. In the quest to understand the true nature of the universe, antimatter remains one of the most fascinating and elusive aspects of modern physics.